Hi students, today in this topic we are going to start Model 4 in Advanced Computer Architecture subject. In Model 4 we are going to see about the multiprocessors and multicomputer is a first topic. In that we are going to see different types of system interconnect in the multiprocessor system, and the next topic is cache coherence and synchronization mechanisms. The third topic is three generations of multicomputer. What are those means? First one is message passing mechanism, second one is multivector and SIMD computers, third one is vector processing principles. Okay, then the next topic is multivector multiprocessors, compound vector processing, SIMD computer organizations. Then the next topic is we are going to see about the data flow architectures. The last topic is in data flow architecture, what is the hybrid architecture and how it follows the fine grain multi-computer system. So these are all the topics which we are going to see it in the model 4. The very first topic is multiprocessor and multicomputer. So before going to see this topic, we need to understand the basic difference between what is meant by multiprocessor and what is meant by multicomputer, right? This topic we have already studied in model 1, but we will have a quick review about its comparison. What is meant by multiprocessor means it is a computer system with more than one CPUs. That means it is a computer system which has more than one processors. Means that system is called as multiprocessor system. Then a multi-computer system is a computer system with multiple processors that are connected together to solve one problem. So here a systems which are connected, those systems are called as individual nodes. These systems are connected and they are working together to solve one common problem. Right, this is about multicomputer. What are the advantages we can achieve in multiprocessor system means it provides the enhanced performance, multiple applications, multitasking inside an application, high throughput and responsiveness, hardware sharing among CPUs. So these are the main advantages provided in multiprocessor system. And then multicomputer, construction of multicomputer is easier and cost effective than a multiprocessor, right? So here construction of a multicomputer, in order to construct a computer, it is more easier. Okay, it is more easier than a multiprocessor system because processors are offering high cost. So in order to build a multiprocessor system, it costs more, but multi-computer system is costing lesser only. So that's what this construction of multi-computer is easier. And where are the application? What are the applications means? Multiprocessor supports parallel computing, multi-computer supports distributed computing. Okay, so these are the applications of multiprocessor and multicomputer. So multiprocessors will be used in the parallel computations and multicomputers are used in the distributed computer. I hope you understand the meaning of multicomputer and multiprocessor. Then next diagram shows the typical arrangement and layout of one multiprocessor system. Okay, in a left side diagram it shows a multiprocessors, that means multiprocessor system assembly with a single shared memory. So here n number of processors are connected, but all n number of processors are sharing a single memory. That memory is called as a globally shared memory. In the right side diagram, it is different from the left one. What it consists means, it consists of a locally connected one memory for each processor. So here also the same n number of processors are connected, but each processor is having its own dedicated local memory. So instead of going for a shared memory which is global, here one dedicated local memory is assigned for each processor. So this is another one variation in the multiprocessor system, right? I hope you understand. Then when we move on to multiprocessor interconnection network, there are two types of interconnection networks are used in the multiprocessor. What are those? Means shared buses, another one is crossbar networks. We have already studied this in the model 1. So here shared buses are nothing but static connections and crossbar networks are nothing but dynamic connections, right? So shared buses, in shared bus the connection between the elements are permanent, which will not be changed. But in dynamic networks, that means crossbar network, the connections are temporary, so they will change its connection based on the demanding situation. So this is about the difference between shared buses and crossbar networks, right? Shared bus means it is a one topology in a network architecture in which a set of clients are connected via a shared communication line. Okay, so it is one of the bus network topology where all clients in the sense all components of a computer are connected in a one shared communication line, right? Here the same bus system is going to be implemented and employed in a hierarchical way, that means level by levels. So what are those levels? Means first level may be local bus and second level is a backplane bus, third one is IO buses. How it is leveled, how it is arranged means we will see the one diagram. Here these four are the major components of your one computer system, right? What are those? Means first one is CPU board, second one is memory board, and third one is IO board, and fourth one is communication board, right? How these are connected means they will be internally connected, and these major components of a computer are connected via one single common system bus. That system bus is shared among four components. How this system bus is employed means it is employed in a level by level. So what are those? Means first one is local buses. So local buses are the buses implemented on a printed circuit boards. This here when you take one local bus in the CPU board, this will connect cache, CPU, IOC, instruction fetch and local memory. Like that the buses will these buses are implemented on your PCBs. So this is called as local bus. Then backplane bus is printed circuit. It is a one printed circuit on which many connectors are used to plug in functional boards. So many connectors are used to plug in a functional board. Buses which connect input and output devices to a computer system are called as IO buses. So likewise, hierarchical bus system is made. Then one more diagram is there. So it shows the hierarchical bus system for a scalable multiprocessor system. It is very important. Scalable in the sense we can add n number of processors in this assembly without changing its design. Okay, how these are clustered, how these are arranged means according to this diagram there are 9 number of processors are connected starting from P0 to P8, right? Then here these 9 processors are clustered in a analogous way, in a logical way. How it is clustered means it is clustered into 3 different clusters. Right, starting from P0 to P2 is a one cluster, P3 to P5 is another cluster, P6 to P8 is the third cluster. So these clusters are going to share the local memories in this assembly using a intercluster bus. Okay, using a intercluster bus, these are going to be interacted with the local memory of its. So here P0, P1, P2 is sharing the M1 memory. Then similarly P3, P4, P5 may share the M2 memory. But these memory communications are done with the help of intercluster bus. So this is what happening in a hierarchical bus system. Here hierarchical bus system is a static network connection where the connection will not be changed. It is a permanent connection. Then next type is crossbar switch and multiport memory. So we know that crossbar switch is a dynamic connection. So when this dynamic connection is acceptable means where and when it will be acceptable means when a machine size is small or medium. When a machine size is small or medium, using this crossbar network is mostly acceptable. But if a programmer or if a architecture wants to have a more number of processes, that means he wants to expand this machine size into larger one, means how this can be done means with the help of multi-stage network connection. Multi-stage network connection is another one type of dynamic network connection where this networks are done in a stage wise, level wise it will be executed, that we have studied in the model 1 itself, right? So this crossbar network system is working in a dynamic way. Here this diagram shows the both type of communication, that means it shows the digital bus communication, that means shared bus communication also, and it shows the dynamic communication using the crossbar networks. The first part shows the static connection using the data bus and address bus and using the multiplexer unit. These connections are permanent. This will share the shared memory in a system with the n number of processors. In the down you can able to see the same set of n number of processors are connected to a shared memory unit using a arbitration logic. So this arbitration logic will be assigns the control to the number of processes at the time of execution. How it is done means with the help of some signal lines. Request signal will be sent from n number of processors, that means n processor to memory. So here processors are considered as the masters and memories are considered as slaves. Likewise it will work, right? So this diagram shows the both the types of crossbar networks and also bus system in a n number of processors in a multiprocessor system, right? I hope you understand this logic. I'll catch you in the next video about next topic. Thank you.